Welcome back, guys. I've just got a quick update on the TEC calculator. This was last updated in 2007 and I've just updated it. Actually, I pretty much finished it finally 10 years later. So I'm not going to go into what every button does and what it all means. That's something you can watch in the previous episode, but I'm going to talk about the new features that I have added. So what I've done now is I've changed the hot side temperature to ambient and I've added the CW rating here. Previously you just changed this temperature and it changed the hot side and it gave you your curve. The problem with this is that you had to really, I guess, come to your own conclusion that the rate at which the delta is increasing is reducing, while the rate at which how much power is getting used is increasing, and you had to kind of draw a correlation that probably is not a good idea to run it at 100%. So what I've done here is I've added in hot side cooling, which if we add that in we get this graph, which is way more useful because before you ended up believing that your actual performance was going to be a lot better than reality. So now we have the hot side, which is getting hotter, and the cold side, which is getting colder to a point and then getting hotter. You've got the yellow line, which is ambient, and the grey line, which is no TEC. So if you just took your 160 watts and you put a cooler on it of 0.1, then you would get whatever that's going to be, 67-ish degrees without the TEC. So we can see that the TEC is helping all the way through to 80%. But we can also see that we definitely should not be running it at 80%, 70%, 60%, and roughly about 50% will result in the best performance. Now if we increase cooling on the hot side, so this is your water cooling, your air cooling, make it 10 times better, then it hugely changes how effective the TEC is going to be. So this problem, if we go back to say 0.2, this indication here is what commonly people experience. They give it, I don't know, let's say 30% power, and as they increase power they're not getting increased cooling, they're just getting the hot side hotter and hotter, and that is because you simply don't have enough cooling on the hot side. Now obviously it's going to be rather dependent on how good your CW is on the hot side based on what kind of performance you're going to get. And so what I've done is I've added this button here which gives us some examples of some common cooling. There's an air cooler there and a few water cooling blocks. Now it's important to realize that the numbers that I've got in here, these are currently pretty much the best water coolers and air coolers around, and if you're not using them then you'd have a higher number. Also the water cooling blocks we've got in here, they're complete systems, and they are at full fan speed, which might be between 2,500 to 3,000 RPM. They're definitely at approximately 48 decibels, and the reality is no one's going to use their water cooling at 48 decibels. So while these numbers might look good and you'll play with those numbers, I can't see anyone ever actually using that. But that's a good guide on what kind of numbers to add. And down here I've moved the coefficient of performance down to here, since this is all power related things. So this is effectively your efficiency, and I've actually added it in here, which is the same multiplied by 100, and that'll tell you how efficient it is. But this change here is really, really useful. So now you can actually get a tangible estimation of how a TEC is going to perform in a certain environment. Now obviously you can play with this. It doesn't include cold side CW. You'd normally have a heat spreader on the cold side. I haven't included that at this time. I don't think it's particularly important. It is something to be mindful of, but it's more important to have that hot side CW, which is really good fun to play with. This only allows you to go up to 200 degrees for obvious reasons. Most TECs actually require you to be under 200, but I've made it to 200, and it makes it a bit easier to see where we're way over. So in that case, the best we're going to get with that cooling is about 20%. And at that point you can see it's really better than just not using the TEC at all and just cooling your 160 watt load with a 0.3 CW. So I'm sure you're all going to rush out and start adding a whole bunch of radiators because it makes a big difference. Alright guys, hopefully you've enjoyed that one. We shall see you on the next one. You can get this from ultrasonic2.com. It is free. You do have to register and pretend to buy it, but you won't be asked for any money. It's free. However, I'd love to see donations so we can keep up some of these videos. And we can all do TECing together. Thanks guys. Bye bye.